Now we're going to talk about double displacement reactions. A double displacement reaction is also called a metathesis reaction. There are three common types of double displacement reactions: precipitation reactions, acid-base reactions, and gas-forming reactions. So these should sound familiar. Some of these were included in our previous homework: acid-base titrations and gas-forming reactions, for example. And then these are all the things that we've seen in our evidence of a chemical reaction: the formation of a precipitate or the formation of a gas. So these are double displacement reactions. Precipitation reactions, to start, result in the formation of an insoluble compound. So that is the formation of a solid from the mixture of two aqueous solutions. So when you have aqueous solutions of lead nitrate and potassium sulfate, for example, we form solid lead sulfate. And you can see here how the lead previously bound to the nitrate and the potassium was previously bound to the sulfate, but they switched positions. So lead becomes bound to the sulfate and potassium becomes bound to the nitrate. So the formation of solid lead sulfate is called a precipitate. So that's where we get the term precipitation reaction. All right. So acid-base reactions are often called neutralization reactions. We neutralize the acid and the base by mixing them together. And you can try to remember that by hearing that water is a neutral pH. You might have heard of that before. It's a neutral pH, and we form that from a neutralization reaction. So an acid-base reaction always results in the formation of water, or at least mostly. I can't think of any examples off the top of my head where that's not true. So our hydrogen ion, our proton, we can also call it a proton, and our chloride ion are bound together initially, and our sodium and hydroxide are bound together initially, but they switch places in our displacement reaction so that we form sodium chloride and water. All right, another form, our third form of displacement reaction, is the gas-forming reaction. Gas-forming reactions, like the reaction between an ionic compound and an acid, result in the formation of a gas, which is often carbon dioxide. So for example, here we have the reaction of nitric acid and calcium carbonate. So in this reaction, we are forming calcium nitrate, water, and carbon dioxide. So our calcium and our nitrate combine to form our calcium nitrate. And then we have two hydrogens and a carbonate ion left over, which are going to form H2O. So we take away one of the oxygens from carbonate and add it to our two hydrogens to make water, and carbon dioxide. So there is our gas that's being formed. So if you see any carbonate, any ionic compound containing carbonate, it's reacting with an acid, so nitric acid, hydrochloric acid, sulfuric acid, phosphoric acid, any of those acids that typically start with a hydrogen, then you are going to form water and carbon dioxide. All right. So some reactions can also be classified as more than one type of reaction. For example, when you have hydrochloric acid added to solid nickel carbonate, you are going to have a double displacement reaction where the carbonate switches places and the nickel switches places, and you end up with nickel chloride. So the nickel grabs the chloride and the carbonate grabs the hydrogens. So this is nickel chloride and carbonic acid. So we call it carbonic acid when it's an acid made from the carbonate ion. So I skipped this step in the previous reaction, but now I'm going to show you how exactly we form water and carbon dioxide. So carbonic acid, decomposes into water and carbon dioxide. So like I said, the carbonate ion loses a oxygen, which binds to two hydrogens to make water. So we end up with liquid water and carbon dioxide gas. Thus, the overall reaction looks just like the one we had on the previous slide. Hydrochloric acid plus nickel carbonate forms nickel chloride, water, and carbon dioxide. So we had a double displacement reaction when we made our carbonic acid, but carbonic acid rapidly decomposes into water and carbon dioxide. So it's both a double displacement reaction and a decomposition reaction. All right, so let's practice. We want to classify each of the following reactions. First, we want to balance the equations and then classify the reaction type. So our first reaction, silver nitrate plus manganese iodide, is forming silver iodide and manganese nitrate. So our nitrate is going from being attached to our silver to being attached to our manganese, and our iodine is going from being attached to manganese to being attached to silver. So nitrate ion displaces the iodide ion, and we end up with silver iodide and manganese nitrate. So this reaction type has two ionic compounds exchanging their partners. So this is a double displacement reaction. And if you notice, we are also forming a solid, so that makes it a precipitation reaction, which I'm going to write as PPT. So it's a precipitation reaction, which is a category of our double displacement reactions. Now, if we want to balance this reaction, we want to have two nitrate ions on the left because we have two nitrate ions on the right. So if we put a 2 here, now we have two silver ions on the left and two iodide ions on the left. So we need two silver iodides on the right to balance our reaction. All right, so what about reaction B? We have carbon monoxide reacting with oxygen gas. So here we have one reactant and two reactants, and we're forming one product. So this one we can call a combination reaction when you have more reactants than products. So is it balanced? We have one carbon on both sides, yes, but on the left we have 3 oxygens and on the right we have 2. So I'm going to, let's see, what should we do? So if we make two carbon monoxide molecules, now we have 4 oxygen molecules on the left and 2 carbon molecules on the left. So if we want to have 2 carbon atoms and 4 oxygen atoms on the right, we just have to make 2 carbon dioxides. So now we have 2 carbons on both sides and 4 oxygens on both sides. All right, so I'm going to break here and go to our next video.